And welcome to the Daily Space Weather Show. If you notice some differences in the imagery tonight, it's because we turned on the Rotate the Field of View feature on HelioViewer. Let us know what you think of it in the comments. That's the past 24 hours from SDO. We're showing the 171 angstroms 60-minute running difference along with the 193 angstroms raw extreme ultraviolet light. The most likely place for a large solar flare remains the southwestern limb, although soon it will also be the northwestern limb. So here's a little closer view of that setting sunspot group. And we're going to zoom in and out in all kinds of wavelengths throughout tonight's video as we bring you the world's most comprehensive daily space weather as well as the most detailed solar imagery you'll find in the known universe. These wavelengths, by the way, are 193 angstroms 60-minute running difference along with 304 angstroms raw data. We do have a number of large plasma filaments on the Earth-facing portion of the solar disk. We'll talk more about those a little bit later in the video, along with coronal mass ejections. And before we get to the rest of that imagery, let's take a moment to take a look at sunspots. So we've had a decline in sunspot number since yesterday. There is the SDO continuum. Here is the SDO magnetogram, and we're going to speed things up tonight. Let us know what you think of the increased pace. And by the way, congratulations on surviving another week almost. Have you heard about the Heard volcano in the southern Indian Ocean? It's like part of Australia or something on the Kerguelen Plateau. There's an effusive eruption going on down there. And yeah, that's a new volcano there on the list, folks. Have you heard about the Heard volcano? Anyway, there's the list, the full list. Sakurajima also on it. Subanosejima, Ibu, Semaru, Popocatépetl. Popocatépetl. Go ahead, come on. You know you want to say it aloud, folks. Popocatépetl. It's on my bucket list. Right by Mexico City, folks. Santiago, Fuego, Nevado del Ruiz in Colombia, Sangay in Ecuador, Revenador also in that South American nation. Also Sabancaya. And if you ain't heard is also erupting. Also, we will cover earthquakes and interesting news here, a possible foreshock situation going on in California. Let's hope not. Foreshocks are often the predecessor to large earthquake events. And there has been another 4.2 magnitude quake in California. So this one's at the geysers. We reported on one yesterday. Here's another one. 2 days in a row with 4.2 magnitude quakes, possibly foretelling of a larger event in the future. We'll get to it here. It was actually, I'll cover it now. It was a little bit more recent there. That one was just in the past couple of hours there at 21:28 Universal Time today on January 26th. Possible foreshocks happening 2 different locations there in California. These are the quakes of a 5 and greater magnitude, starting out with a 5.4 north of Ascension Island, right near the equatorial portion of the Atlantic Ocean there. Also, Papua New Guinea had a 5.1. That was at nearly 100 kilometers estimated depth. Japan near the Izu Islands also had a 5.3. And that's it. Those are the only quakes of note besides this 4.2 at the geysers, California. So that said, let's get back to some space weather stuff. How about some stats? The 10.7 centimeter radial flux is at, I have no idea, but there's the 1 year graph. It's at like 161, I think it is. So yeah, there's the 1 year graph. Some Solon.info, 157 is the current 10.7 centimeter radial flux. 157. If you're not familiar with the radial flux, it goes along with sunspot number, folks. It's a direct correlation. High sunspot number means high radial flux and vice versa. So there's the sunspot number up top, radial flux down at the bottom there, directly proportional solar features of the solar cycle. And what's interesting about this is that NOAA is indeed forecasting continued geomagnetic storm and geomagnetic unrest conditions. So we continue to agree as we've seen multiple Earth-directed coronal mass ejections. And there you can see NOAA agreeing with our forecasts once again. What we haven't seen are any good impacts. So no geomagnetic storms have been happening. I wonder if NOAA's getting mad about so many false positives. We prefer to forecast all of the CME impacts on the channel. We forecast more like NASA than NOAA. Anyway, without further ado, here's some more space weather information for you. These are the past 4 hours of Earth's magnetic moment from space as modeled by the Space Weather Modeling Framework. By the way, we've got a very interesting feature on the meteorology segment tonight, so make sure you stay tuned for that. We also premiered the latest Ask a Particle Physicist segment just before this video was produced. Next, the last 4 hours of Earth's magnetic moment from the ground. And again, let me reiterate, we've got geomagnetically calm conditions for an extended period here, which were not what we were expecting. We were expecting some geomagnetic storms. We ain't got none so far, so the impacts have been ultra weak. As the sun continues to just behave like a plasma miser, folks. Plasma miser. So, next the KP index is currently at 1.67. There it is. 1.67. And here are the real-time solar wind informations. So there's the ACE showing a nominal solar wind speed and a nominal solar wind density. The Discover, a little denser, and a similar speed there. So only about 9 protons per cubic centimeter there at the Discover. 460 kilometers per second. Every time it looks like it's going to get good, like right in here, the negative BZ signal goes away, getting rid of the geomagnetic the likelihood of geomagnetic storms. Because that red line, when it's negative like that, is a good thing for the generation of aurora. So this is a little better here, but not a very strong field there, only 5 nanotesla. Make it 6 nanotesla with a BZ of -3. Anyway, next are GOES magnetometers. There you go. That's the past 3 days. No big variations in that, as space weather has not been happening. Next is our top view ecliptic plane field plot. As Earth is getting closer to a sector boundary crossing there, about to move into a North Pole heliospheric magnetic sector, but that still could be as many as 2 days out. I would say probably more like, I'm not sure, at least 36 hours out. That's my guess. I would say probably more like about 2 days for the sector boundary crossing, where Earth snaps into a North Pole magnetic heliosphere sector. Next, the line of sight field plot, which depicts the solar B field, the photosphere magnetism, and the polar fields. Next, the coronal hole line of sight plot. So that's what's going on, and here come coronal holes from SDO. Again, we changed the field of view setting here. We decided to rotate the field of view on most of these videos tonight. Let us know what you think, if you prefer the rotating field of view or the stationary field of view when it comes to the heliosphere, the Helio Viewer movies. So here are 2 wavelengths good at showing coronal holes together. 171 angstroms. That's the 60-minute running difference imagery, along with the 211 angstroms, which is fantastic at showing coronal holes. We've got a very well-defined couple of coronal holes here on the Earth-facing portion of the solar disk, which brings us to sunspots. There are the sunspots in terms of the Royal Observatory of Belgium sunspot number, and down below 100 now. We've only got 83 sunspots or so. Here's the synoptic map, and there still is a likely chance of large flares, although not as likely here, according to the magnetic shear. There is the synoptic map, brought to you by NOAA, the Space Weather Prediction Center. So there you go, and you can see that NOAA agrees with me here that the most likely place, well, actually they're calling 3559 more likely to produce large flares. So actually we disagree there. So I say 3560, oh, now wait a minute. 3561 and 3559 are equally likely to produce large flares. So there you go. So that is an agreement. I agree. Moving along to our flare probability monitor and scoreboard here. Now it's animated for your viewing pleasure. And let's just view sunspots here from SDO. There is, once again, 171 angstroms, 60-minute running difference along with the continuum. And there is just continuum by itself. We do have some new sunspot groups forming here in the east. So there's one right there that just spontaneously formed and another one up there to the north of it. So 2 new groups just formed as 2 new groups rose, and those groups that rose are barely sunspots. I think there are 2 umbrae there, so we'll see. We should see an uptick in sunspots between today and tomorrow, despite the setting of these groups in the southwest. That's my estimation, and I'm sticking to it, like Rain Man counting toothpicks or something. What does he count? He counts a thing. He counts matchsticks or something. I don't know. Anyway, moving on to energetic particles and solar flares, we ain't got no energetic particles. GOES proton flux is flatlined, and the GOES X-ray flux here not exhibiting any large flares. Just a couple of large C-class events. No M-class solar flares, and here come flares. That is 94 angstroms running difference, along with 131 angstroms the raw imagery. Get off my screen, casting button. Why is that crap on my screen? Get out of here. Anyway, here are those rather uninteresting groups that rose up over the eastern limb. They are plages for the most part. There are a couple of tiny umbrae there, but so far, not very exciting looking sunspots. Again, this remains my favorite place for a large solar flare at the moment, at least for the next about 36 hours. And here, just for some added bonus, we've included the 171 angstroms with 335. Fantastic imagery there, courtesy of the Solar Dynamics Observatory. Moving right along to a star chart. As I want to know what's going on overhead, don't you? Well, head to skyandtelescope.org and make one like mine. Put in your location, and there you go. Saturn is setting in the southwestern sky here over Lehigh Valley, Pennsylvania at the moment, as Castor and Pollux make their way across the night sky, and Jupiter up there near the apex of its path across the ecliptic. Next, our solar system forecast will show you where things are today, right there. That's where things will be in a week, right there. Here is the astronomy photo of the day. And, you know, some channels on YouTube, they spout a lot of bull, if you know what I mean. Yeah, they spout a lot of bull, right? Well, we don't do that. We do facts. But there are the eyes of the bull in the constellation Taurus. Aldebaran is one of those stars, and the other one is, I don't know. But that's the astronomy photo of the day. And there's all kinds of interesting features there that you may be interested in. So first of all, Epsilon Tauri lies 146 light years away. It is a K-type red giant, which is, I believe that's this one. It's 13 times the solar radius and nearly 100 times the solar luminosity. Meanwhile, the brighter giant star, Aldebaran, that is the other eye of the bull. And yeah, one of those has a planet. I don't know, apod.nasa.gov. I'm over it. Let's get the CMEs, as it's not getting any earlier tonight on Friday night. So here are CMEs, and what do you got? That's some stuff going on. It's pretty mild as far as the action, but we do think we have another couple of CMEs on the way here. So NOAA and I agree that there is still some geomagnetic storm condition likely, citing several coronal mass ejections. So that one, unfortunately, I don't think is earthly directed. Let's take a little closer look at that before we skip to our custom coronagraphs. Yes, custom coronagraphs. They are created just for people like you. So here we go. These are 24-hour videos, once again, all synced up with LASCO C3, LASCO C2, and SDO in the middle. Filaments on the Earth side of the solar disk look like they're holding steady for the most part. And I don't see any likely Earth-directed CMEs from this. If you disagree, let us know in the comments. If you're mad, let us know in the comments. If you're happy, let us know in the comments. If you're jealous, let us know in the comments. If you have herproids, do not let us know in the comments. We do not want to know about your herproids. Continuing right along, there is, that's not too bad. That's pretty sweet imagery. What do you think, folks? What do you think? Not too bad. And there is an even closer view. That one CME was from right up here, right in that area there. Didn't look like it had an earthly directed component to me, but hey, you never know. Sometimes you just wish you were wrong. Unless you don't care about facts and things like science, then you just want to be right regardless. That is for people who are dogmatists as opposed to, I don't know, pragmatists, realists, scientists, stuff like that. Anyway, let's get back to some more space weather stuff before I go off on a huge tangent. There are filaments from the Cerro Tololo, Chile ground-based solar observatory. Some prominence is there in the east. This is the more interesting one. It's just a little bit better depth there, as it's not grayscale, and several large filaments here on the Earth on the Earth side of the solar disk. Let's bring up the latest and count those briefly. What do you got? 1, 2, 3, 4, 5, 6, and there's at least one other one that's like down here somewhere, or maybe down here. I don't know. But several quite large and quite dense filaments. We've already named a couple of them. I forget which one's called which, but one of these is Kimberly Nichols and one of these is Renee Gable. If you want to name filaments after your friends, your foes, or even yourself, join us over on Twitter, x.com/smashomash. Just follow the hashtag #NameThatFilament. And you, too, can participate in America's favorite pastime, being censored on the internet. America's favorite pastime, being censored on the internet. Anyway, before we get to bonus features, here are the past couple of hours from the GOES 16 SUVI, and things are looking pretty chill. So let's move on to bonus features and meteorology and our particle physicist segment and so forth. There is the charging hazard scenario. It is smooth sailing for satellites. No charging hazards at all. GOES electron flux is quite low still. There's the 1-year graph. You see how low the electron flux is? There it is. There's a forecast model expecting it to be even lower, and I tend to agree with that because, again, additional CMEs likely incoming. Next, we'll show the ionosphere, the layer where it's measured using radiography, and I won't get into the explanation of that either, but that's the layer, the F layer, at 300 kilometers of altitude. Here it is in vibrational frequency. We show it daily on the channel because you never know when you have amassed data that might be usable for something. So never underestimate the power of archiving information that is otherwise inaccessible. Our channel has been doing that for over 6 years. We're actually pushing 7 years of daily space weather content, having missed only a handful of days in the meantime. So that's the raw vibrational frequency. Here is the anomaly in megahertz from a 30-day median. And if you're used to looking at that, you'll see that that's not very anomalous. The ionosphere looking real normal. So we apologize that we're unable to forecast the apocalypse with this ionosphere data. Let's also show the WHAM, the whole atmosphere model. Wham! The whole atmosphere model, folks. There it is. GPS users, pay attention to the left. Radio users, pay attention to the right. Here's the last portion of the space weather segment. The daily space weather. There's the latest continuum. There's the latest magnetogram. Again, these sunspots in the east are looking pretty weak, but at least there is some growth happening there. Check it out. We've got a group that has already evaporated up there and a group that is evaporating down there. These new groups that rose are looking weak as well. Only one umbra there and only one small umbra up there, I think. So not a lot of new activity there showing up. Next, we'll get to our meteorology segment. We're going to start out by looking at total cloud water. Yeah, TCW, baby. TCW. What, you don't look at TCW? What are you, some kind of a crazy lunatic? Look, total cloud water. What are you, out of your gourd? Total cloud water, y'all. I mean, what the heck? Of course, that's at the surface layer. Oh, that's just depicting wind at the surface and total cloud water. So, not half bad. Pretty cool map there. It's like the blue marble, sort of. Like simulated. Anyway, figured I would show that, and now I'm going to show wind patterns. So there is the surface wind scenario for the east, the jet streams of the east, the jet streams of the central world, the surface winds of the central world, surface winds of the Americas, and the jet streams. Next is our Ask a Particle Physicist segment. So if you haven't contributed, why not go set up a login at smashomash.com/forum? That's the best place to contribute. Now, we'll take a question from anywhere, but, typically I'm going to post it in the forum. So that's what the forum is for, the free exchange of information, where censorship isn't a thing. So anyway, the Ask a Particle Physicist segment is next, hosted by the monotone from Minsk. It's Eugene the Philosopher. Make sure you subscribe to his channel, or there will be blood and guts, and carnage, possibly carnage of your soul in the river Styx, where it'll be reincarnated as a total noob. Subscribe to his channel, or else. Eugene the Philosopher. Again, the segment is brought to you by Eugene the Philosopher. And you can contribute at smashomash.com/forum. Just go to the General Science Forum and go to the Ask a Particle Physicist segment. You, too, can contribute a question. Here come today's antics. I won't get into reading the question. And by the way, these videos, they get released only on the space weather video for Friday. There's a playlist that includes the previous Ask a Particle Physicist segments by themselves. However, the Smash team does not get... The Smash team, Gold and Silver, are the only ones that get access to that by itself until next week. And there's a whole premiering thing that happens, and I'm not going to get into it. But anyway, without further ado, here is today's Ask a Particle Physicist segment from January 26th, 2024.
All right. The question we have is, what do you think of the claims that humans can and do control large-scale Earth weather patterns? And the motivation for the question is here. So basically, some people believe that there's a global conspiracy of some sorts, you might say, for various alleged reasons, as it says here. So apparently humans have been doing some wicked stuff to obtain some even wickeder results, or something to that effect. And yes, humans have been doing some of this. Like cloud seeding is a well-known technology. Like the aerosol injection experiments have been made multiple times, like with the space shuttle program, but not only that. Solar radiation management is a fairly, well-developed branch of, geoengineering techniques and things like that. You might even say like terraforming techniques in general. Doppler radar arrays, I haven't heard much about that. Like, is that a conspiracy theory of its own? I don't know. But yeah, controlling the weather. And HARP obviously is also a well-known project. Um, yeah, so can it control the weather, basically, is the question. Well, these techniques that I've mentioned, I mean, they have been used, right? The spraying in the skies have been done, like we know that. There have been a scandal, I remember, in Germany a few years ago when people spotted a plane which was not present on like services like flight radar, and it turned out it was a big scandal because it turned out it was a military plane and it was actually spraying something, including some heavy metals, and people got pissed off, and understandably so. But if we're talking about like chemtrails in air quotes from passenger planes, then I can, well, okay, let's just put it this way. It might happen, but it probably is not happening. This is my opinion. Like I know a guy who works as a like a maintenance part of the maintenance crew on airliners here in Belarus. Like I don't know about other places, but here in Belarus we definitely do not add anything into the fuel. We definitely do not put anything additional on board of the planes, etc., to spray or whatever. But as a philosopher, I kind of would like to examine the problem on a more fundamental level. Maybe it would be helpful. So, think about it this way: can we predict the weather at least a week ahead? I don't think we can, right? So, like every day you add, like the fidelity of your models drops like by tens of percent, right? So basically, 2 weeks later, everything breaks down completely. So we don't even have a way of predicting the weather with the known parameters. And how are you gonna control the weather by introducing some additional input into the system? Let's say we spray something, like we heat up the ionosphere above certain place or whatever. Uh, you can't even predict the with the known parameters, and you're adding something else. Basically, what I'm saying is weather is a chaotic system. It has been known for at least 70 years, I think, since the Lorentz studied the behavior, the equations that govern the airflows and things like that. So yeah, it's a chaotic system. There's no way around it, and therefore it's unpredictable. So at best, what you're gonna do with your additional input is just make the result even more chaotic potentially. So yeah, you can, I guess, you can play with it a little bit to try to figure out maybe there are some directed impacts that you can make. I mean, maybe there are some rigid, solid types of correlations. Like we heat the ionosphere here, and like certain specific parameter responds in a certain specific way. Let's say a week later, maybe you can try to find that, and maybe that's what they've been doing with this HARP program. Like I haven't actually studied it because, to be honest, like I'm not interested in it at all. But it's the best you can hope for. Find some minor effect, some minor good, strong correlation, but you can't really control the weather in general. Like it's a highly complicated system. It's not even a system; it's a medium in the first place, right? You can't even use like the systemic approach to study it. It's much more complex. So yeah, that would be my answer, my fundamental answer, that controlling the weather is impossible because the weather is chaotic, period. So yeah, so people certainly try to find some effects, they study it, but I mean, it's still in its infancy. Like we need a completely novel mathematical approach. We don't even have the basic ontological entities to describe the weather properly. Like it's quite obvious that regular methods, perturbation theory, for example, they don't work here. You need something else, and we don't have this something else yet. At least I don't think we do. Maybe some people from some high top secret level military people have it, but we don't. Regular people don't. And I mean, to be honest, military people are usually dumb, right? They're stupid, so they don't really have it probably either. Yeah, that would be my short answer. You can't control the weather because it's chaotic, period.
By the way, I don't influence these at all. I just submit the question and then Eugene answers it. That's it. There's no collaboration whatsoever with respect to answering the question. I send it, he answers it. Thanks, Eugene. Don't forget to subscribe to his channel. And thanks for viewing our Ask a Particle Physicist segment. Let's get to meteorology. As planned. Clouds and fog over the U.S. and South America. And a quick reminder to never attempt to sneak up on a dragon in its lair. It won't work. And here's a view of the very strong thunderstorms and gravitational wave emanating from that low pressure. As higher pressure sets in, there is a pressure gradient there, as you would expect. But some amazing thunderstorms over the Gulf. Let me pan over a little bit to get a better view of those. That is some serious action. Some huge pressure variations happening there, and you can see it reflected in that low shelf cloud as well as, well, the formation of huge thunderstorms that just stay fixed in place. Anyway, we've also got some shocking freezing rain to cover. In New England and New York, it's disastrous right now for everybody who's trying to drive. Now, of course, sometimes freezing rain can be mitigated, but anything besides studded tires on major freezing rain, and it's quitance as soon as there's any kind of a gradient. I'll just say that. So, yeah, precipitation type is what we're showing. Here is our weather.gov map. Lots of floods are expected, both as a result of runoff and direct flooding from precipitation. Here come the forecasts. First, I've returned. These are the forecasts. There's pressure and precipitation. Oh yeah, snow coming to PA. Woo! Now keep in mind, folks, my commute is 20 feet. My commute is 20 feet. So that's why I'm like, yeah, bring on the snow. Why? Because I know how to forecast weather, and then I mysteriously don't have to travel when it snows. That's some planning for you. Anyway, look at the ridiculous rain coming to the Pacific Northwest also. Some areas there with over 6 inches of rain. So that's, damn, what the hell? Look at the floods. Jeez. That is some serious rain right there. So, yeah. Significant floods in various locations. I'll just say that. So then we'll have some slushy snow showing up here in Pennsylvania. Some nice slushy nuisance snow for PA. That'll be fun, right? Next temperature anomaly. And it's kind of warm for this time of year. The coldest time of year in North America really is mid-January through mid-February. And it has been colossally warm. Couple deep freezes, but no extended deep freezes. So, continuing right along. By the way, those came from tropicaltidbits.com. Look at this thunderstorm that's been going on in the Gulf. It's still going on. That is abso-smurfly berserk. So that's like the past 10 hours. That's like a 10-hour... Look at that. There's just sustained lightning. We apologize if we've opened a gateway to hell with this much lightning. For those of you who think the lightning is man-made, please, we've experienced technical difficulties while opening this gateway to hell. Anyway, it's still going on, though. Like I said, here's lightningmaps.org, and it's a real-time lightning map. And what the heck? That is a berserk thunderstorm. Look at that. It's just like hanging out in the same place for at least 10 hours. I'm not going to run a longer run, but anyway. Here is the U.S. Doppler radar. Man, oh man. Here is clouds and fog, water vapor, dag, huge pressure gradient right there. There's an atmospheric waterfall happening right in here. Classic. Just classic. Recap. Lower 48. Clouds and fog. Water vapor. Closing out before the video is too long. May that solar wind be at your back. I'm going back to the bunker. Whoa.